Okay, now to the formal notes. That was the longest do now ever, but I think it was important. Okay, pairs of inequalities. Here's the definition of compound inequalities. Pairs of inequalities connected by and or are called compound inequalities. Solutions of compound inequalities can be graphed on a number line. So if we graph the solutions of x is greater than -1 and x is less than or equal to 3 on one number line, I would recommend at first just graphing them each separately. X is greater than or equal to -1 would be open circle at -1 because it can't equal -1, but it can equal any value greater than -1. Arrow to the right. X is less than or equal to +3, so a solid circle at +3, and an arrow to the left. Now when it says and, it means anything that's in this solution set and that solution set. Not either or, and. So you see the overlap starts at -1 but does not include -1. And then everything overlaps all the way until we get up to 3, including 3. So this is the solution set for the compound inequality, which can also be written, I'm just going to rewrite this, x is greater than -1. Then I'm going to go from right to left. X is less than or equal to 3, so x is less than or equal to 3. You know, I never really gave this much thought until this exact moment, but it might be best to have the smallest value on the left side. And so if I put the larger value on the right side, I could just copy that. And then I could go x is greater than -1. That kind of shows you the interval notation better, where the interval, all of the possible values of x start at -1, but do not include -1. That's why there's an open circle here. And this says greater than, not greater than, or equal to. So parentheses. All the way up to the greatest value, which is 3, and does include 3, so brackets. Okay, I'm going to clear some of this off because I forgot there's something underneath here that I want you to see. Okay, to satisfy a compound inequality connected by and, that's nice, the solution must satisfy both inequalities of its and. The solution of this type of a compound inequality is the intersection of the two solution sets. So intersection is that upside down U.